Hey, this is Mr. Drogemeyer. Thanks for joining me for our Algebra 1 lesson videos. Today we are in Unit 8 looking at lessons 10 and 11, modeling with systems of equations. And so we've been doing all kinds of different things with these systems of equations. In this one, start with a vocabulary term, and it's actually a term that we've used before. The term is constraints. And basically a constraint is a restriction that is going to be put on variables used in equations in these real world situations. So there's going to be some limitations or some kind of boundaries. And we'll see once we look at an example here how that factors into some of these problems. So in this first one, it says a person has 290 coins, entirely quarters and dimes. So just quarters and dimes, 290 total. And it has a total value of $50. We want to write a system of equations to represent this situation. So we know there are 290 coins altogether. I'm going to define my variables. So I'm going to use X to represent their quarters and Y to represent the dimes. Well, I know that in total they have 290 coins. So if I add the number of quarters, which is X, and the number of dimes, which is Y, that total is going to be 290 coins. So that's going to be one of our equations. Then the second thing that we know is that these coins are going to have a total value of $50. Well, each quarter is worth 25 cents. So 0.25, if I multiply that by the number of quarters, that will give me the value of those quarters. My dimes are each worth 10 cents. So 0.10 times the number of dimes, which is Y. When I add those two dollar amounts together, it should equal $50. And so this would be my system of equations for this particular situation. They didn't ask us to solve it, so we won't go through those steps. But when we talk about constraints, one of the constraints here, or the main constraint, would that be that X and Y can't be negative, because it doesn't make sense for me to have a negative number of quarters or a negative number of dimes. And so that's where we're talking about constraints here in these real world situations. I did go ahead and graph this in Desmos. So let's take a look at that real quick. So there's my green is the number of coins, that equation. The black line represents the $50, that dollar amount. And so we can see there's an intersection here. And so if our solution here would be 140 quarters, 150 dimes, that total dollar amount would be $50, and it's also our 290 coins. All right, then let's take a look. We have one more example here. It says at an art fair, an artist recorded sales of 46 candles of 2 different sizes and a total of $275 collected. Smaller candle sells for $5, larger candle sells for $8. Again, we want to write a system of equations that can be used to find the number of smaller candles, X. So X is representing the smaller, and the number of larger candles, Y. So Y is our larger candles. All right, and so thinking of our equations here, we know that we're going to sell a total of 46 candles. So X plus Y, number of smaller candles plus the number of larger candles, needs to equal 46. And then the dollar amount, $275 total that we're collecting. Well, we know that the smaller candle is $5, so 5 times X. Larger candle is $8, so 8 times Y. Those are going to be our equations in our system. And again, it doesn't ask us to solve the system, but I did go ahead again and use Desmos to graph this. So let's take a look at what that looks like. There's our X plus Y equals 46. Our 5X plus 8Y equals 275. And so in this case, our intersection here, 31 of the smaller candles, 15 of the larger candles That's our total of 46. And when we take the dollar amounts, that's going to be $275. Again, constraint-wise, no negative values. We can't have a negative number of candles. So that's where that vocabulary term that we mentioned, constraints, comes in. All right, that's all I've got for you for this lesson. I appreciate you taking the time to watch. As always, if you have questions, please let us know. Thanks. Have a great day.